Right. Hello, everyone. A big thank you to each and every one of you for joining us today for this session. My name is Wen Gakuo. I lead the Angular Kenya community, and today we have one of our guest speakers. Our guest speaker today is going to be Kang Tran, and he's going to be taking us through Angular signals, zoneless change detection. What does this mean? How does it work? And how does it supercharge even your workflow? And what does this mean for you as someone who is not necessarily just getting into the Angular ecosystem, but also someone who's interested in seeing like how can you deploy or have an application that has like proper state management and all. So without much further ado, I'd like to hand it over to Kang to introduce himself, and then he can go on. All right, over to
Yeah,
you, Kang.
yeah. Thank you so much. I'm hello everyone. So I'm Ken. I'm a software engineer from Vietnam. So this is my very first time being as a speaker at a webinar like this. So I would like to thanks to the Angular Kenya team for setting up everything and making this happen. So what I want to do today is kind of take you guys along some of the things I've learned about Angular change detection in signals. And I'm not the expert in any of this, so this is going to be me taking you guys along my learning journey and nothing more. So let's start this section with the reason why I'm end up here talking about this topic today. So the journey started with this kind of error message. If you have been working with Angular for a while, I bet you have encountered this kind of error at least once. The expression change updates have been checked. And when it happened to me, I had no idea what Angular was actually complaining about. So I went to the Stack Overflow and find the solution. This solution is that wrap the mutation in a set timeout. I tried it and the arrow disappeared like magic. And I have no idea why it worked, especially when I reached to the comment section. People were basically saying that fixing the arrow like that is not considered best practice. So this become a starting point for this talk. It's led me with two questions. The first one is that why the Angular threw this kind of error in the first place? And the second one is why the set timer make this error disappear, but still feel like a wrong solution. And then back in 2023, when Angular Renaissance started by introducing a new primitive for the framework, a lot of ideas from that RFC were interesting, but one line really stood out to me. This is one of the benefits when we're using the Angular signal, the better rails to avoid common pitfalls that lead to poor change detection performance and avoid common pitfalls such as expression change after 7 check errors. And to be honest, that were confused me again. How could a new reactive primitive can help Angular avoid this kind of errors? So these questions are what pushed me to go deeper into the Angular change detection. And to answer those questions today, we have to understand what Angular actually doing during the change detection by building the mental model from the ground. So before we talk about signals, let's step back to the basic question, what is the change detection? And at the simplest level, change detection is Angular keeping your application state and the render UI in sync. So whenever a state changes, the UI should reflect that change. This is a simple idea, but to solve this problem, we Angular need to answer two questions. When it should run the change detection, and the second question is what part of the UI it should update. So to make this concrete, let's start with a tiny example here. So here's the same idea in plain JavaScript. We have some state, the name here, and we also have some UI, this bin here. But the important thing is that there's no connection between the DOM and the name state. So changing the state doesn't automatically update the string. That's the reason why we have to have the render function here to connect them together. Nothing changes on the screen until we call this render function. But it leads to a problem here. To make everything stay in scene, whenever state changes, we have to call the render function manually. So let's imagine in the real application, state can change from many places, like click event, timer, API response. So this means we have to remember to call the render function in all of the places. And this is the problem Angular solves automatically for us. So how does Angular know when the application may need to update the UI? So this is where Yarn.js comes in. Instead of us manually tearing Angular every time they may have changed, Angular used Zone.js to intercept the common async callbacks in the browser by monkey patches every browser event. Things like click event, timer, process, promise, HTTP response will be purchased by the Zone.js, and when those callbacks finish, Zone.js will notify Angular to run the change detection. But the important detail is that Zone.js has nothing to do with the update UI. It only tells Angular something just happened, so something may have changed. Let's give Angular the first answer when to run the change detection, but it doesn't answer the second question, what actually changed. So after receive the notify from the Zone.js, Angular need to respond to that notification by running the application red.tick to figure it out itself. So that's because I mentioned in previously, Node.js did not deliver any information about what changed. Angular need to start the change detection from the top to bottom. It starts from the root component and work down the component G. Or technically, Angular will look through all of the component and run the detect changes for each of them. But now we can ask more interesting question here. When Angular reaches one component, what does it actually check? So here, when Angular reaches a component, it does not guess what to update. It needs instructions. Those instructions enter two questions. What value should Angular read from a component, and where should those values go in the DOM? That injection set in the template function. So to see what inside a template function and what is template function look like. So let's just go to the next slide. It look like a low level, but it's really answer the question that we raised before. So here's the compiled template of our example, and you can see that there's two separate slots here. The first slot is the reaction phase, and it's responsible for create the DOM structure, and it's only run once when the component initialized. And the second block is the update phase. So this part is exactly the one that Angular will call when run during the change detection. So here you can see that Angular read the name property from the component instance, and that's the bind read. So Angular write this value into the text node inside the heading one here. In the phase one, it create a text node here. And but now we have one more question. Where does Angular remember the previous value? So it knows whether the DOM actually needs to change or not, because whenever we write to the DOM, it costs a lot. So we need to try to optimize here. Only run the update DOM when the value is changed. And Angular remember the previous value inside something called the L view here. So think of the L view as a Angular internal storage for the current view, and technically it is an array, but the important part is what it stores. And as you can see here, it stores like the heading text node, the component instance, and one thing that we need to keep in mind this one, that the Angular also keep the value for the binding inside the L view here. So for example, it's remember for the binding of the name here, that the last value is fit for the name binding either John. So this is exactly what makes the comparison possible for the next step. So now let's follow the update part of the from the template function, and let's get back a little bit from the template function here. You see in the second phase here, the Angular will trigger the text interpolate function, and inside this instruction, Angular run the binding check, the binding updated here, and you can reference the symbol mental mirror here. It's basically something like the binding update will try to read the previous value from the L view and then try to compare it with the new value. And if there is nothing changed, the update will be skipped. But if there is a change, then it will call the corresponding function like update stat node, and by the end of this, it will reach to the renderer to set the function, and the value will be updated to the DOM. So the concept here is that reading the binding and then compare it with the previous value. So if it changes, then store the new value back to the L view and then update the DOMs. And it's exactly the render function that I saw from the very beginning example. And in the development mode, Angular does not stop after the first track. It asks one trigger question like, if Angular runs the template again, do the binding still produce the same value? To answer that, Angular run immediately can the template function one more time after the first pass. In the dev mode, it also runs the check no changes. And in this part, if any value of the binding is return a different value, Angular knows something changed too late. And this is where Angular will lose the value that we see from the very beginning. The expression changed after it had been checked. So now let's get back to our code from the very beginning. At first glance, this code look completely normal. We start to set the value to John, and then the Angular with the value, the name value, and after that, after the view initialize, we change it to DOE. The value itself is not a problem. Angular is not complain about the value change from DOE to John. The important detail is when that change happened. So let's change the template step by step to understand why Angular threw the this issue here. So we will work through from the left to right here. So first, Angular run the change detection part. It reads the binding and it remembers John here. But after that, when the life cycle hook entry attribute in it kicks in, it tries to update the value to DOE. And here's the mystery part. When Angular run the second pass in the dev mode, the check no changes, it re-evaluate the template function, and now it see the new value DOE, but the previous value is stored with John. So that the exact exactly reason why Angular threw the arrow here. So let's get back to our question from the very beginning. Why, when using the set timeout, everything is fixed like a magic? So set timeout does not make the mutation suffer. It simply moves the mutation out of the current gene detection cycle. During the current cycle, Angular just runs the register the set timeout, but the callback has not run yet. So when Angular run the check no changes, it's to see John again. So the value is still the same. So it's not through the arrow here. And later, then the timeout callback runs in the new browser stack here. It assign the name to the new value though, but after text finish, Zone just notify Angular again and Angular run another text to update the UI. So yes, this set timeout work, but it works by escaping the current check and it's not fixing the real timing problem. That's exactly the reason why a lot of people in the comment when I just through the Stack Overflow say that the using the set timeout to fix this issue is not a best practice. And now we can answer the first question from the very beginning. Why does Angular throw the expression change after it's having check issue? The answer is the unidirectional data flow. Angular check the component from top to the bottom. So once Angular has checked the binding and move forward, the binding is expected to stay stable for the rest of the pass. So Angular is not complaining about the value become dull. Changing the value is normal, but the problem is that it becomes dull after Angular have already checked the binding. So in other words, the change happened too late in the current pass. If Angular keep going back every time something changed behind it, one change detection pass would no longer have a clear meaning here. So in the development mode, Angular runs the second check to catch it. And when it see the value change after it was checked, it will use the arrow NG100 here. That's exactly the rule that the NG100 protects. Now this brings us to the next part. Zone.js can tell Angular when something happened, but it cannot tell Angular exactly what state changed, and which will depends on that state. For that, Angular needs a different synchronization model that is exactly where the signal comes in. And now we can compare two models together. For the Zone.js, as we discovered already, it gives Angular taming information. It tells Angular something happened, a fallback finish, maybe the UI needs to update, but Zone.js does not know what state changed, and it does not know which part of the UI depends on the state. So Angular has to check roughly and reply on the idea that in one pass everything should stay stable, but with the signal give Angular something different. So they give Angular the dependency information. When a signal changes, you can know which views consume the signal. So the SIP, it is John.js say something happened, go check, but for the Angular say this state change and this view are affected. So the next question is that how does Angular know which view depends on which signal? So the answer is the reactive graph. For example, we have a this is the example of the reactive graph. For our example, we have the first node here is the name here. This is the producer, and the second node here is the app root template, and this is the consumer of the name signal. So when the template run and reads the name, Angular records this relationship, and it now knows this template depends on this signal. So later, when name changes, Angular does not have to guess which part of the UI may be affected. This wrap already gives Angular the answer, name change. And the app root template is one of the consume that depend on it. But the next question here, like, how does the template become the reactive consume in the first place? So this is the Angular's specific part. When Angular refreshes the view, it runs the template with a reactive consumer that attached to the L view. So while the template is running, Angular knows this view has an active reactive consumer. Then if the template reads the name, the signal system see that read, and it is happen because the producer access function here. So when the read of the name is no longer just a normal function call, it's become the dependency information. This is how Angular create the edge between the name and the app root here. So what happened when the signal changes? So one of the confusing part for me when I'm learning about the signal is that when we call the set function, Angular does not push the new value directly to the template. It pushes just the dirtiness. So when we call name.set here, Angular makes the reactive consumer for this view as dirty. So it basically saying this view depend on the name and the name has changed. But the new value is not written into the DOM immediately after the signal itself. So later, when Angular refreshes the effective view, the template runs again. Then the template calls name again and pull the latest value. So the model is not push the new value everywhere. The model is push the dirtiness and then the pull the latest value during the refresh. So now we can back and review our original example with the right mental model. So with the same component here, same entry after unit timing, but now the name is the signal. So in the first check, the template with the name get John and will store John in the area padding. But at the same time, the signal risk record the S from the name to the app root template consumer. Then after entry after unit run, it set the name to do, change it, the value of the signal, and the area button here is still shown in this case. But now Angular knows that the template consumer is dirty. So Angular can refresh the effective view. The template reads the name again, get dull. The binding update compare the old value, the John, to dull, and update the every slot. And it's write the DOM again. So signal does not remove the view or the binding update. The difference is the mutation is visible to the Angular. So Angular can synchronize the effective view instead of only discovering the change waiting too late. And this is where the Angular model changes from change detection to the synchronization. And this is answer to everything we have been building toward. In the classic checking model, Angular runs past and expect the will stay stable. If something changes later, Angular crashes in the dead mode and throw the expression has expression change after it has been checked. But with the signal, Angular has more information. If a signal changes during synchronization, Angular can see that change. So it's make the affected view expected react to consumer dirty, and then it can refresh that view again and continue until the UI becomes stable. But Angular still has the sub limit for this look. Um, but the important difference is this the signal mutation is visible to Angular when it happens. So Angular can incorporate that change into the synchronization process. This is the shift from one pass that expects stability to the synchronization process that works until the affected views are stable. Now, that's explain everything and also every question that we have set up from the beginning of this talk. And I think it's also ended my talk for this section. So, do you have any question for this one?
Hi, thank you. Thank you very much, Kang. I think that was a very good um, overview and at least of a deep dive in terms of what exactly signals are and how it compares to normal change detection that we're used to. And I think one of my key takeaways in this case was um, signal does not push values, it pushes datiness, and then templates pulls the
Yeah,
values. That was a
yeah,
really good. That was a really good point. Where to makes it easier to even understand the concept of signals, and I like the way that you did the comparison between when you're using signals or when you're not using signals. That was really good. Does anyone maybe have any question they'd like to ask? Please feel free to drop it in the chat. Well, as someone is asking a question, uh, maybe can could maybe tell us in terms of so people are kind of confused between signals, RxJS. When and where do you get to use it, and is it something that is it signals or RxJS, or it could be the normal saying of it depends.
yeah. For this kind of question, like when we decided to use the signal or the ASGS. So, for example, when you have something and you render it in the template, so this is exactly the good the best practice where we need to use the signal. But for some cases, like a very complex workflow that involve the time event time or something like that, we need to use the SGS for this one because there's when it's come to complexity for some cases like when you want to prevent the button click in multiple times or something like that, you need to use some kind of function from AJS like switch map, exhaust map, or something like that. So for just simply using the signal, you cannot handle these complexity business that involve the time event.
Okay, thank you. Thank you for that. And then when it comes to let's say developer experience, what's your experience with signals over the traditional way of handling change detection and state management based on
Yep.
your personal experience?
Yeah, so based on my experience in the past, like we have very difficult to understand the change detection of the Angular because we have two modes like the default modes. Right now, we in the new version it changes to the ego change detection, and we also have the on-put change detection. So sometimes it's confused for someone who joined to learning Angular. And when the signal introduced, if you use the signal and apply the signal for across your application, then you don't need to care about the on push or the default mode anymore. Because, for example, when you use the default change detection and you have some normal property, you use it in the template, and then you change the change detection mode to the on push, then your application will be Rex. But with the signal, it will handle the change detection under the hood by the Angular itself. So it's know when exactly the value is changed. It will schedule the change detection, notify Angular to run the new change detection cycle. So everything will be in sync without us carry about our implementation.
Yeah, thank you for that. Yeah, and I think right now, even with the on push being now the default strategy, change detection strategy in V22 and above, it's going to be much easier for people to work with signals because I think before that, even after signals were introduced, there's always that recommendation of make sure you add change detection on push strategy to work with signals better. So yeah, that's good to see that the developer experience is also improving. We have a question from name called I am Horse, asking, can you share signals between unrelated components?
Um, I'm sorry, I cannot get it.
Uh, I think maybe I am Horse is probably asking when it comes to if you want to share signals. Um, maybe I think maybe on a service level, is it possible to share it in different components? I think that's maybe.
Yeah, say the signal between the different across different component, right? So in this case, if you want to share the signal across the component, we need to involve the services here. Like you introduce in services, and the services will contain the state of your application, and you can introduce like a private signal property inside the service. And for the let's say in the component A, you can inject the service and use a signal, and also in the component B, you also inject the same service and use this kind of signal. So it's like exactly the same the way that we used before with the ArcGIS. Before we have the behavior subject, uh, before the signal error, we still use it as a main state management for the Angular.
Yeah, yeah. Thanks for that response. Yeah, I think as Pang has mentioned, like, yeah, if you want for that kind of situation, is just involve the service. So put your signal at the service level, and
Yeah,
then you can be able to just make use of them whenever you inject them, whenever, whatever.
yeah,
Um,
and
yeah,
also I think another solution is that you can like move the state up one level. For example, like you have the component A and component B under the same parent, but you want to share state between them. So to make it possible, you need to move the state to the parent component, and then you can share it to the component A and B by using the input like the normal way that we use the Angular.
yeah. Thank you. Uh, I hope we've been able to answer your question. I am host. In that case, saying that okay, he's saying in Swahili that he's late. Yeah, don't worry. In that case, this session is going to be available even right after this. You'll still be able to just play it back and then just go through it. I mean, it's a really great session, so I'd really, really recommend that just play it back. Yeah. So I am host is like, yeah, as soon as like this question has been answered. Um, yeah, I mean, I think now, I think with the advent of now signals being even more easier for people to understand as well, I think it's becoming okay, from our personal perspective. I think I found it much more cleaner when it comes to event state management. And
Yes.
uh, I think before then, when we used to use behavior subjects and all that, was quite challenging, and just trying to wrap your head around what exactly is happening with subjects. It's kind of like a foreign thing,
Yeah.
and I'm happy to see that Signals have made this much more this kind of like state management much more cleaner, and even making any new developer to come in and really understand like, okay, what exactly is happening. Yeah. So so maybe you could just give us not necessarily a deep dive, but how does this even maybe compared to what we have now with signal forms? Is it kind of the same concept where we it's not pushing content, it's just pushing the datanets, and then forms are pulling in the values, so on and so forth? Like how does that compare to even signal forms?
Compared to the signal form,
Yeah,
um, I'm sorry because recently I didn't have involved too much to the new signal form topic, so
yeah.
I cannot have enough insight to compare between
All right.
them. But as let I have tried it out myself in behind the scene. The
Yeah.
signal form it use the signal under the hood, so the mechanism is exactly the same. Like when the value changes, it also put the dirtiness to
Yeah.
the consumer, and the and there's not happen until you reach the value again.
Yeah.
So is it possible I'm just saw some stacklet for just here, then I can explain better about the post dirtiness concept here. I think it will be here. Yeah.
Yeah, I think just borrowing from your presentation, I think it could be more or less the same thing. But of course, forms could be in a different level, but I think the concept might still remain the same.
Yeah.
Yeah, I don't know if there's anyone else has any question. Any question? Okay, it seems there's no question. Um, okay, just trying to check as well on our socials if there's anyone who has a question. Okay, for now, not yet. All right. I think I think this was a really great session. And it's an opportunity for us to like learn more about some of these new features that are just coming in, to make the developer experience, of course, better, or at the same time also allow beginners to start off at a great place, because I think Angular a few years back it would not have been as easy as it is today. The learning curve was quite steep, but we're glad to see that some of these new features are coming in. Candy J says that she's here to gain more knowledge. Welcome, Candy. Yeah, don't worry, we are kind of done, but there's no need to worry. You can still be able to play this back so that you can be able to like learn more about signals and zoneless change detection and Angular and how what really happens under the hood. And I think Kang really did a
Yeah.
great job to give us
Yeah.
that sneak peek of what really happens under the hood. I don't know, maybe Kang, do you have any parting shots? Do you
You
have any?
know. Yeah.
Okay.
Yeah. But you also mentioned a lot about zoneless change detection. I didn't include it into my presentation, but maybe I can have some software here.
Yeah.
Like I also go through this the process here. Also, like when the signal changes, it will push the value. It will push the terminate to the consumer. But beside that, it's also the one thing is that it will notify the new scheduler of the Angular. So it will move to the zoneless because in the past, your JS is the one that who responsible for notifying Angular when something may have changed. So right now, if we move to the zoneless, we need to have the new mechanism that responsible for the same responsibility. So Angular introduced a new casual mechanism, I think from the version Angular 17.2. If I remember correctly, that we have the new casual mechanism. Like that is something involved with the Zoneless topic.
Yeah. Yeah. So yeah, I think with it now being very zoneless, I think it makes it even easier for people to at least also understand what really happens when it comes to change detection. I think that's usually one of the key questions you're actually asked. You're asked about change detection and then what happens in a Zone.js application and a zoneless application. So that is
Yeah,
something for anyone who is applying for jobs, especially Angular related. Just make sure you know the difference between Zone.js apps and zoneless change detection, and like how does that even work. Yeah.
yeah,
Yeah. So if you want to learn more about Angular signals, we've shared the link to that. Just go to angular.dev/guide/signals. But of course, if you still want to go back and still learn more and just understand what happens under the hood, you can always play back this video. If there's no any question, I'd like to bring the session to a close. I'd like to say a big thank you to everyone who has been able to join us today. I want to say a big thank you to our guest speaker for today, Kang.
yeah,
And we just had a conversation before we started this live session. He said like he used to be one of our audience, and really happy to see him like coming in and actually being a guest speaker. So on behalf of Angular Kenya, I'd like to say a big thank you, and we hope to see you come to Kenya at some point, attend our annual conference as well, NG Kenya, which we usually have every year. Usually happens around in August. So whenever you feel that you'll be at a best point to join us, feel free to join us for NG Kenya, even if it's next year, because I know maybe this year will be too close.
yeah.
Yeah. So for those who have not grabbed the ticket, just go to ng-kenya.com. Should be able to grab your tickets for our upcoming Angular conference, which is going to be happening on the 21st and 22nd of August. It's going to be a 2-day conference. So be sure to grab your tickets. And thank you for everyone who has been joining us from wherever. Appreciate it. And thank you for also taking the time. On behalf of Angela Kenya, to everyone, have a great evening and a great week ahead, and see you in the next webinar.
Yeah, thank you everyone for joining today.